Hello, you're welcome to this presentation. This is my second part or presentation on the basics of capital budgeting. In the first presentation, I did look at the net present value, the NPV method, and in this presentation, I'm going to focus on internal rate of return. And then in my next video, I'll look at the modified internal rate of return. So let's see how this method is used when it comes to making capital budgeting decisions. And I'm going to use the same example, just a simple example that I used when I was looking at the net present value. So here we have two investment projects, L and S. And both investment project requires some initial outflow of $100 each or 100 millions each, depending on how you look at it. But then, of course, there's a cash inflow uh, for L and also for S. But the difference is they have different inflows. Where in L, you have 10, 60, and 80. And then for S, the inflows is 70, 50, and 20 over a 3-year period. So, what we're trying to do when it comes to the internal rate of return, we are trying to find a measure of this investment. In other words, we're looking at a return which is going to be as a percent for this investment, where the that rate or that percent makes the NPV of either L or the NPV of project S to equal to zero. So our focus is what's that percent that it's going to make all these cash flows net present value be equal to zero. So it's similar to what we did when we are looking at the net present value, but the only difference here is we are looking for that percent that makes the NPV zero. And this is basically the formula. If you think about it from a mathematical perspective, this is the formula that you can use to derive or to find what that internal rate of return. So again, if you look at the formula, we are looking at where you can a rate that you're going to use to discount all the cash flows, and then when you sum all those cash flows, they equal to zero. So what is that return? What is that percent? This is what we are trying to determine, is that percentage that will we could use that to discount all the cash flows, and it makes the net present value equal to zero. Again, there's so many ways you can do this. Again, you could try to use the formula as you're seeing here. You could use again the financial calculator by using again your cash flow key, and then of course find out what the IRR is. Or you could also use Excel. Which I'm going to use is how we use Excel to determine the internal rate of return. So we're going to see how we apply this method to just these two examples. And then, of course, what is the number telling us? How can we use this to make decisions? Will be our focus as soon as we finish up with the computation. So let's look at how we determine the uh, the internal rate of return, and I'm going to look at the use of Excel. That's what I'm going to use. So I'll be using that one. And let me just take you to those two cash flows. So this is the cash flows that we have. And I'm going to pick up Excel. And what I did, I already keyed in our cash flow for project L and also for project S. So again, we know that both projects require some initial investment of $100 each, and then of course in year one, two, three, you have some positive cash flows. Again, you could have negative cash flows maybe in year two and so on, but just to make this simple, we're assuming this is a 3-year project that has those kind of cash flows. So if we are going to use a calculator to determine the internal rate of return, again, yeah, our internal rate of return is going to be, again, you key in the values. Our values again is 10. Again, you could key one by one if you want to, but what I'll do is I'll just select the cash outflow and select all the cash flows. And then the next is to guess what that rate is, because we're looking for that rate that will equate the net present value to be 0. So I'll enter, and in this example I found this to be 18.13% as the internal rate of return for project L. And for project S, again, I will do the same thing. We are looking for internal rate of return. Again, this is the cash flows. You select all your cash flows, and then of course you enter, and this will give us a 23.56%. So if you're thinking in terms of the making decisions, so you have an 18 and you have a 23. So in terms of making a decisions, we found that our IRR for project L is 18.13%, and for project S we found this to be 23.56%. So in other words, again, the assumption of this method is all those cash flows are being invested or reinvested at the internal rate of return, which is, again, this example is going to be 18 for the L cash flows and 23 for the S cash flows. Remember what we said with the net present value. With the net present value, we assuming the cash flows are being reinvested at the weighted average cost of capital. In our example, we are using 10 as the weighted average cost of capital. In this example, our weighted average of capital again is still, because we're using the same example, so it's still 10%. So in one, your entitled to return is 18. For the other one is 23. So how do we then use this information and make some financial decisions? So the rationale for this method is this: if the internal rate of return is greater than the weighted average cost of capital, in our example, again, remember, weighted average cost of capital is 10%. And our IRR, it depends with which project. In one project was 18, in the other project is 23. So you're looking at L and S. Again, in this example, both of them, both the internal rate of return is greater than the weighted average cost of capital. For this example, then, the project return exceeds its cost, and that is the cost of capital. Therefore, there is some return left over to boost their stockholders' return. So you're basically saying you're getting more than the cost of capital. So there's something left over. So there's some excess. And because of that, again, you'll accept the project if the IRR is greater than the cost of capital, and you reject the project if the IRR is less than the weighted average cost of capital. But again, this will also depend on the nature of the project. If project L and S, if we're talking about independent projects, then you're going to accept both if internal rate of return is greater than the weighted average cost of capital. In our example for project L and for project X, you're going to accept both of them because there's an 18% and a 23% as the internal rate of return, which is again more than the 10%, which is the cost of capital. If these projects are mutually exclusive, where we are saying that the cash flows of one project affects the other. So if that's the case, then we will only accept the project that has the highest internal rate of return. So assuming L and S were mutually exclusive. If L and S were mutually exclusive, then of course what you're going to do, if they were mutually exclusive, then you're going to accept only project S because it has the highest internal rate of return, which is 23 versus the 18. But again, remember the assumption here, the cash flows are being invested or invested at the internal rate of return and not at the cost of capital. You ask yourself, is that possible? You know, I'm guessing you're going to say it's possible not. And therefore, because of that, that becomes a limitation of this method because it's not possible to reinvest the cash flows at a higher rate than the cost of capital. So because of that reasoning, this method has its own limitations and therefore it's not possible to do to invest this at the internal rate of return. For example, in this particular case, for that reason, most likely, people will not use this method. But of course, managers prefer this method, but ideally speaking, it's not the best approach. But again, you get the point of how we determine the internal rate of return and how we use it to make a financing decision. So I'll be looking at the next presentation, which is going to cover a modified version of this, a modified version of the internal rate of return, which is basically the modified internal rate of return, the MIRR, and we're going to see how that method is applied. So see you then.